All right, so let's look at the bell work. Two Coca-Cola bottles without replacement. So this is compound probability because we have two choices to make. We're going to have a probability for the first choice and then a probability for the second choice. And just like the fundamental counting principle, when we have to make multiple choices, we multiply the number of options together. What's the chance that when you reach out and grab a bottle off this table, very first time, you get a Coca-Cola bottle?
A 10/16 chance.
10/16. Because 10 of the bottles on the table are Coca-Cola and there's 16 bottles total. All right, so it says without replacement. So after you grab that first bottle off the table, you set it off to the side somewhere, and then you go back to reach again. Thank you, sir. What's the probability now of selecting a Coca-Cola bottle? 9 out of 15. And so when we multiply those two together,
90 over 240.
90 over 240.
Simplify down to 3/8.
It does simplify down to 3/8. Did anybody change that into a percent, perhaps? What would that be as a percent? Yes. So as a decimal, 0.375 or 37.5%. Beautiful. I would accept any of those. I would also accept 37.5%. Unless the directions on the test on Wednesday specifically ask you to return your answer a very certain way, like leave your answer as a fraction, write your answer as a percent. Those are going to be places where I'm looking for that. But if the...
At this time, all AP U.S. government students need to be released to the main gym. All AP U.S. government students need to be released to the main gym. This afternoon, it'll be AP chemistry and L109. Thank you.
If the directions do not specify how you're supposed to give your answer back, I will take it in any of the forms that we've discussed. All right, second one on number 1, 2 Pepsi bottles with replacement. What's the chance that the first time you reach to the table, you get a Pepsi bottle?
6/16.
6 out of 16. It says with replacement, so this time you pick up the bottle, open it up, taste test it. Yep, it was Pepsi. Screw the lid back on, set it back on the table. You turn around, somebody mixes them all up. You select a second bottle off the table now. What's the chance that the next time you do this, it's a Pepsi bottle again?
The same.
Same, 6 out of 16. So we multiply those two together.
36 over 256. Simplify down to 9/64.
36 over 256, or that does simplify down to 9 over 64. As a decimal,
0.140625.
0.1406, so 0.141, so about a 14% chance that you can do this. The last one did not specify whether it was with or without replacement. Does that make a difference?
Yes.
Yes, that does make a difference. Let's calculate this both ways. Let's do it both with replacement and without. So with replacement, what's the probability that first we get a Pepsi bottle and then we get a Coca-Cola bottle?
6/16 and then a 10/16.
6/16. Multiply that by 10/16 would be with replacement. So if we replace these bottles, we would have a 60 out of 256 chance. That does reduce down if you want to reduce it. Most of the time with probabilities, it is perfectly fine to not reduce your fractions down. In fact, that's usually the preferred way. Without replacement, what's the chance that we get Pepsi followed by Coca-Cola?
6/16 and then 10/15.
6/16 and then 10 out of 15. There would still be 10 Pepsi bottles on the table, but now there's only 15 bottles total. So 60 out of 240, which actually reduces down to 1/4. So a 25% chance if you are not going to replace the bottles. All right, last one on the bell work. A medical researcher needs 6 people to test the effectiveness of an experimental drug. If 13 people have volunteered for the test, in how many ways can 6 people be selected? Is this a combination where the order that you would select the people matters because they're going to be treated slightly differently? Or is this a combination where the order that the people are selected in does not matter because everybody ends up being treated the same? This is a combination. It would not matter if I went in alphabetical order by first name or last name, or whether I chose people and read their names off based on their ages. The 6 people that are selected are all going to be part of the group that's tested, and the 7 people that are not selected are going to be part of the not tested group. All right, so we would have 13 combination 6, 1,716 different ways that this group of volunteers could be put together. And that is 1,716 unique groups. So there's something different about each one of those groups that could be put together. All right. We are done with our bell work for today. Like I mentioned while we were going through the bell work, your test over this is on Wednesday, so I'm going to pass out the review to you today. You guys are going to have a work day to work on that. And this time around, instead of one side of a piece of paper, we've got one of the larger sized index cards. I will pass those out to you. You get front and back on this. So it's a little bit less space, but we also have a little bit less as far as, formulas and processes to go through. All right? Okay. Let me know if you guys need any help. I'll pass out your reviews. One other thing I wanted to make you aware of. On Canvas, there is a similar but different review. So if you'd rather complete the review on Canvas, that's fine. Or you can complete the review on paper. You can do both of them. If you do both of them, I will throw some extra credit your way because they are different. And for the paper version, I have posted the answers here so you are able to check your work just like you can with the Canvas version. I'll have the solutions up before the end of the day today so that you can look through those as well in case you're like, you got this answer, I have no idea how you got this. I've looked at it 3 different ways. I'm still quite confused. All right? Please let me know if you guys need anything at all.